Hey guys, Mr. Rast here. Today we're going to talk about converting and using metric prefixes. So in front of you guys right here, we've got a list of prefixes going all the way from exa down to auto, with the symbols and the meanings and the scientific expression all written on this here. So if we take a look at like mega, it would be represented with a capital M. And what that means is whatever the base unit you have, that would be 1 million of them. So it could be 1,000,000 grams, 1,000,000 tons, 1,000,000 liters, whatever it is that you're talking about. In exponents, it would be 10 to the 6th because there are 6 zeros here. Centi is a C. It is a 100th, and it's represented with a 10 to the 2nd. So that's just some basic nice table here, but I have found in the past that a lot of students have troubles with this in that they confuse sometimes like what a giga is. I have students often, they'll say that there are this is a thousand or thousands, millions, billions. So they might say that there's 1 billion gigagrams per gram. That's not true. It's that for every 1 gigagram, there's a billion grams. So I want you guys to pay attention that these units here, it's how many of the base unit you have for these units here. It is not the other way around. A lot of times students mess that up. So if you'd like to pause the video and take notes, I would suggest writing it down this way, because simply noting it in this format, a lot of times people make mistakes. In my class, my students, you guys are going to be required to know giga to deca. These are the large ones that I want you guys to have memorized, that we'll be using these kind of things throughout the year. When we use very large numbers, we'll be using things like this. And for very small numbers, I need you guys to remember deci all the way to nano. And again, for every 1 deci, it's a tenth. So for every 1 decimeter, it's a tenth of a meter, not the other way around. People often will write things like centi. They'll say that there's 10 to the negative 2 centimeters, or 10 to the negative 2 meters per centimeter. And I'm sorry, that's the correct way, but sometimes they'll write it the other way. They'll say 10 to the negative 2 centimeters per 1 meter. So this side here is the equivalent. I don't want people getting confused on that. And you need to go from deci all the way down to nano. This is when we're talking about very small things, like perhaps the diameter of bonds or molecules or things like that. We might be using very small prefixes like these ones that I need you to have remembered: deci, centi, milli, and micro and nano. Note that milli is an M, and when we came to micro, we already used the M. So they used a Latin, I believe it's Latin, symbol. It's called a mu, and it has a tail in the front of it. So make sure that you know this symbol. It's not a typo. It's not something strange with your screen. That's what it is. Okay. Now, when we're converting, a lot of times people are comfortable with just moving the decimal place over a few times because it's a 0, and you just kind of move 2 times over for centi or something like that. But I want you guys to practice. This is the method. It's more important than the answer, in my opinion, right now. And the method I want you guys to be comfortable with is dimensional analysis. We'll be using this method quite often throughout the year, especially when we get into concepts like stoichiometry. I need you to understand dimensional analysis, and so this is the foundation right now that will help us later on when we do these types of problems. Sometimes teachers call it, or you might look up called factor label method. So dimensional analysis or factor label method are common ways that you'll see this procedure of converting. So if we look here, can you write 725 millimeters as meters? The first thing you need to do in all word problems is figure out, what do you already know? Well, we know because I'm asking you guys to memorize your prefixes. You have to know that for every 1 millimeter, there is 10 to the negative 3rd meters. Or in other words, it's there's 1,000th of a meter per 1 millimeter. That you need to know. Now, you're going to go back to your algebra class on canceling things out that are on the top and the bottom of a fraction. So you're going to set this up, this equivalence here, you're going to set this up, 1 millimeter is to 1,000th of a meter. You're going to set this up to cancel, to get rid of units. And in this case here, we're going to take 725 millimeters, and we're going to multiply it by 1,000th of a meter, 1,000th of a meter divided by that 1 millimeter. We set it up this way so that the millimeters cancel out with each other. And the crowd grows wild because you got it right. 0.725 meters would be the answer here. Now I want to show you how showing your units can help you get questions correct that you might have normally got incorrect. If you don't show your units, a lot of times students get confused. They're like, I don't know, should I divide by 0.001 meters or should I multiply by 0.01 millimeters or meters? Dimensional analysis is a trick that lets you always know should you multiply or divide. So if we take a look at the first example, let's say we set it up this way and we show our units. If we show our units, we'll be aware if we made mistakes or not. And I'm trying to figure out where my mouse pointer is. Here it is. Okay, it's got an arrow in there. I don't know why, but whatever. We'll use it that way. So if I set it up this way, my millimeters, it's going to be millimeters times millimeters divided by a meter. So if I did it this way, my answer would be 725,000 millimeter times a millimeter is a millimeter squared divided by a meter. So when I show my units, I can tell, what is this? I don't know what this is. Now I use dimensional analysis. The whole point of dimensional analysis is to setting up things to cancel out. So right here, my millimeters and my millimeters cancel each other out. And what has left over is my meters. So in this situation, I know I'm multiplying by the 1,000th of a meter. So it would be 0.725 meters. And that makes sense. That's what I was trying to do. When you show your units, you'll realize this doesn't make sense. What is this? I don't know what that is. This is not the way to do it. Nothing canceled out here. Students often don't like to show their units. They just want to multiply and divide and they do stuff and they don't show their units. Showing your units is how you'll make sure you get questions right. Showing your units is the whole point of the process of dimensional analysis. All right. So let's do another practice one with dimensional analysis. Can you write 25 inches as feet? All right, well, pause the video and give it a try. Okay, what did you get? Let's see what you did. So you should have, doing what we did before, write what you already know. You know that for every 1 foot, there's 12 inches. Okay, hope you knew that. And step 2 is set this up to cancel. Since we have 25 inches, we're setting up this equivalence of 1 foot is equal to 12 inches so that the inches cancel out. So that the inches cancel out, so you have to have an inch as a numerator. Inch as a numerator and inch as a denominator. They cancel out. Your leftover unit is feet. So 2.1 feet is what 25 inches equals. Now sometimes we can do multiple conversions at once. So we're going to do a little more challenging one. We're going to convert 7 centigrams into micrograms. And I know some people just move the decimal place over and count. I understand you can do that. I understand that's an easier way to do that. I'm talking about the process of dimensional analysis. That's what we're doing right now, the process of dimensional analysis. So if we know our prefixes, we know that 1 centigram is equal to 1/100th of a gram. We also know that 1 microgram is equal to 1/1,000,000th of a gram, okay? Or 10 to the negative 6. So when I do this, I'm going to set up multiple stages. If you notice the first stage here, I'm getting rid, I always set up to cancel. So I see here that I have 1 centigram equal to something. So since I'm starting with centigrams, I'm going to get rid of that centigram. So I'm starting with 7 centigrams. I want to get rid of it. So I use this equivalence right here. And that gets rid of my centigrams. But what it gets me into, it has to be an equivalent. What it's equal to is 1/100th of a gram. Well, that's nice, but the question I'm supposed to answer in micrograms. So I use this equivalence of 10 to the negative 6 grams, and then I can convert that into micrograms because I know that for 10 to the 6 grams, it's 1 microgram. And we cancel out our units. The centigrams cancel out. The grams will cancel out with each other. And now we have our answer in micrograms. So it's 7 times 0.1 divided by 10 in the negative 6. Okay? And that would be 7.0 times 10 to the 4th micrograms. Always show your units, show them canceling out, and always answer in proper units. No work, no units, no credit. That's the policy in my class. All right, guys, here's some practice problems to go through. Again, when I write my tests and quizzes, I look at the things we did. I'll look at these lessons, and I'll look at these examples that I have here for you, and I'll just change the numbers and change units around, but it will be similar to this, so practice this. This is a great foundation for what we will be doing in class soon. Thank you. If you have any questions, please ask. I'm more than happy to help. Thanks.